A man dies alone in his apartment. Days pass. Nobody notices, except his dog, who stays beside the body the entire time. It avoids food. It refuses to sleep. It simply waits. This behavior contradicts the standard biological survival loop. Typically, an internal stimulus like hunger triggers a direct output, foraging. When the bonded human is removed, that loop breaks, the output fails, and the biological machinery halts. This failure occurs even in animals with fully intact survival skills. Physical dependency on a provider cannot explain why a healthy organism would choose to deteriorate. This presents a specific ethological paradox. An internal mechanism is actively overriding the evolutionary directive to stay alive. Historically, behavioral science categorized these relationships through the lens of resource conditioning. Animals performed behaviors, humans provided rewards. But the resource model cannot account for extreme grief. Animals do not exhibit this biological shutdown for every human who provides food. The response is specific. The physiological breakdown only occurs when the animal is separated from the specific individuals it has bonded with. The mammalian nervous system processes these emotional connections as requirements for survival, using the same urgency it applies to food or water. This shifts the investigation from animal love to a more clinical question. Why has the mammalian brain evolved to use emotional pain as a survival mechanism? Evolution built this system to solve the existential threat of isolation. For a social mammal, being alone is a death sentence. This phylogenetic tree shows the emergence of a specialized attachment system. This biological architecture ensures that group members remain physically and emotionally close. To prevent separation, evolution wired the brain to interpret social isolation as a literal, immediate physical threat. In the mammalian brain's architecture, an input for physical injury routes directly into a central threat and pain response hub. Social isolation routes into that exact same hub. The brain uses identical hardware to process a broken bond as a broken limb. Humans often describe emotions as high-level, civilized concepts. In reality, our feelings are governed by this ancient neurobiology. The physical sensation of heartbreak is an active biological alarm designed to force a mammal back toward the safety of the group. Clinical data from separation experiments with domestic dogs provides a very clear view of this system in action. If these animals operated on instinct alone, they would simply move on to a new provider when the bond is broken. Instead, data shows a physiological crisis. This dashboard compares a grieving human with a separated dog. In both, cortisol levels spike in synchronized patterns. These similarities continue into secondary symptoms. Both subjects display erratic REM sleep cycles and sustained elevated heart rates over long periods. This eventually leads to a complete physical shutdown, a state that mirrors the clinical markers of human depression. The prolonged nature of this deterioration suggests the bond is a foundational emotional structure, not a temporary habit. These symptoms represent a standardized cascade, a physiological response to loss documented in multiple social species. This process is known as identity reorganization. The animal integrates the bonded human into its own internal framework of reality. The human becomes psychologically important, necessary, almost like part of the animal's identity. This framework exists even in species with vastly different cognitive structures and evolutionary paths. Elephants will return to the bones of family members years after death, demonstrating a psychological persistence of the bond. Because the human is a part of the animal's identity, the loss of that human can cause the animal's psychological baseline to collapse. In shelters, some animals become permanently detached after being abandoned. They enter a state of emotional numbness as a response to repeated trauma. This suggests that the architecture of attachment is a universal biological language, and the cost of losing it is the same across different minds. While we study the animal's dependence on us, we rarely investigate why so many humans feel emotionally safer around animals. Modern human interactions are often transactional. Our social matrix is built on performance and status, creating constant friction for the nervous system. Animal feedback is different. It is consistent and unfiltered, evaluating only the physiological reality of the person in front of them. They track our facial expressions and vocal tones with high precision. This allows humans to feel physiologically seen without the exhaustion of social performance. This offers an explanation for why the loss of a pet can feel so uniquely destabilizing. The animal was the only predictable anchor for their attachment system in a complex social world. We are drawn to the honesty of animal emotion because modern life requires us to filter and suppress our own. An animal embodies its emotional state. It does not intellectualize its grief or joy. It presents it as an immediate biological truth. Science can map the hormones and the neural pathways, but language still fails to fully capture the subjective experience of this connection. What the data confirms is a shared hardware. Across different species and different minds, the internal architecture for processing connection and loss is the same. This suggests a definition of consciousness based not on intelligence, but on the ability to emotionally matter to another living thing. The intensity of an animal's attachment serves as a mirror. It reminds us that beneath technology and language, we are still creatures desperately searching for connection.